Okay, so I will be going over the analysis of strokes. My name is Helen Gardner, and this is for Molecular Biology, Bio 363. A stroke occurs when something blocks blood supply to part of the brain or when a blood vessel in the brain bursts. In either case, parts of the brain become damaged or die. There are 4 types of strokes. There's an ischemic stroke, a hemorrhagic stroke, a brain stem stroke, a cryptogenic stroke. An ischemic stroke happens when a blood vessel supplying blood to your brain gets blocked by a blood clot. Most strokes are this type, so this is the most common. A hemorrhagic stroke occurs when bleeding in your brain damages nearby cells. There are 2 types of hemorrhagic strokes, which depend on where bleeding occurs. Brain stem strokes occur when blood supply to the base of the brain is stopped, and cryptogenic strokes is a result of 2 or more causes referred to as a negative evaluation and incomplete evaluation. More specifically, an ischemic and hemorrhagic stroke. Ischemic, it results from blood supply being stopped to a portion of the brain, which can lead to reduced blood flow and oxygen to the brain, which can lead to death or damaged brain cells. Hemorrhagic results from a brain bleed from an artery or portion of the brain. This leads to decreased functionality to the affected area of the brain, causing the brain to not function correctly. I have provided a photo here of an ischemic and hemorrhagic stroke, which you can see the blood clot here, and then the bleed out. Tissue plasminogen activator, also known as TPA, is classified as a serine protease. A serine protease are enzymes that cleave peptide bonds in proteins. It is thus one of the essential components of the dissolution of blood clots. Its primary function includes catalyzing the conversion of plasminogen to plasmin. Plasmin is the primary enzyme involved in dissolving blood clots. Examples of these drugs include alteplase, reteplase, and tenecteplase. Alteplase is the normal human plasminogen activator and is FDA approved for managing patients with ischemic stroke, myocardial infarction, STEMI, acute massive pulmonary embolism, and those with central venous access devices, also known as CVAD. Reteplase is a modified form of human TPA with similar effects, but a faster onset and longer duration of action. It is currently FDA approved for the management of acute myocardial infarction. This one is preferred over alteplase due to its longer half-life, allowing it to be given as a bolus injection rather than through an infusion like alteplase. And then the third one is tenecteplase, and is another modified version of TPA with a longer half-life. Its indication is the management of acute myocardial infarction. And then this is a summary of action of TPA. It's basically 4 steps. TPA attaches to the fibrin on the clot surface. It activates the fibrin-bound plasminogen, and plasmin is subsequently cleaved from the plasminogen affiliated with the fibrin. The plasmin break up the molecules of fibrin and the clot dissolves. So, plasminogen activator inhibitor 1, so PAI1, eventually terminates the catalytic activity of TPA by binding to it. And this inactive complex PAI1 bound TPA is removed from the circulation by the liver via the scavenger receptor, LDL receptor-related protein 1, LRRP1, and in the nervous system, a neuronal specific inhibitor of TPA, neuroserpin, acts similarly to PAI1, and the LRRP1 internalizes the inactive TPA neuroserpin complexes from removal from circulation. So this is just a little analysis of the different types of strokes and how TPA can be used to treat them.